Hello everyone and welcome to the presentation on software testing techniques with the V model. My name is Ahtesham Shaikh and I am currently pursuing MC at Vishwakarma University. In this video, we will explore how software testing ensures quality throughout the development lifecycle. Whether you are a student, a developer, or just curious about testing practices, this session is designed to give a solid foundation. Let's begin by understanding why software testing is so important. Software testing plays a crucial role in ensuring quality and reliability. It helps minimize defects and bugs, leading to smoother user experiences. By catching issues early, testing reduces development cost and avoids expensive rework later. And of course, it boosts user satisfaction by delivering a product that meets expectations. Ultimately, testing helps us validate that the software meets the original requirement, making sure we are building the right thing. To test software effectively, we rely on some key principles. First, testing shows the presence of defects, not their absence, so no software can be declared perfect. Exhausting testing, checking every possible input is impossible, instead we test smartly. Early testing is critical, bugs found earlier are cheaper to fix. Then there's defect clustering, which means a small number of modules usually contain most of the bugs. The pesticide paradox reminds us that repeating the same test won't find new bugs. We need to update tests regularly. Also, testing is context dependent. What works in one project might not suit another. Finally, the absence of error fallacy. A program can be error free and still useless if it doesn't meet user needs. Let's look at the V model. The V model is a visual representation of the software development process paired with its corresponding testing phases. It shows how every development activity has a corresponding test activity, forming a V-shape. The left side represents verification, ensuring that we are building the product right, while the right side represents validation, which makes sure we are building the right product. It also emphasizes early testing, aligning testing activities with each development phase from the beginning. The verification phase focuses on reviews and inspections. In requirement analysis, we verify that the software requirement meet user needs. In system design, we check whether the high-level system architecture makes sense. In architectural design, breaks this down further, reviewing how components interact. Finally, in module design, we look at the detailed design of each individual module. Now let's talk about validation process in the V model, which focus on testing the actual system. It starts with the unit testing where the individual modules are tested to ensure each part functions correctly in isolation. Then comes integration testing which checks how this module interact with when combined. After that, system testing validates that complete software system to ensure it meets all specified requirements. Finally, we have acceptance testing where the user or client tests the software in a real-world environment. These phases ensure that the product is ready for the release and meets business expectations. Unit testing focuses on testing the smallest pieces of code, like individual functions or methods. It's usually done by developers right after writing the code. The goal is to catch bugs early before the code is integrated into larger modules. There are two types of techniques used here: black box testing, such as equivalence partition and boundary value analysis. Then white box testing, like statement and path coverage. This testing ensures that each component behaves as expected, making it a crucial first step in quality assurance. After unit testing, we move to integration testing, which checks how different modules work together. Sometimes components work fine on their own but fail when connected. This testing focuses on interface and data sharing between modules. There are three main approaches. First, top-down integration, which starts from high-level modules. Second, bottom-up integration, which begins with lower modules. And third, sandwich integration, which combines both. The main goal is to detect interface issues, mismatched data formats, and communication errors early in the process. System testing is done once all modules are integrated. It tests the complete application to ensure it meets the original requirement. Independent testers usually perform this phase to maintain objectivity. It includes two main types: functional testing, which verifies if features work as expected, and non-functional testing, which checks performance, usability, security, and more. This is the phase where we simulate real-world user scenarios to ensure the software can handle anything users might throw at it. Acceptance testing is the final gate before a product goes live, and it plays a crucial role in determining whether a software is truly ready for real-world use. At this point, development and internal tests are complete, and it's now time to put the system in front of the actual users or clients. There are two main types: user acceptance testing and business acceptance testing. UAT focuses on checking whether the system is user-friendly, initiative, and behaves in a way the user expects in their typical workflows. BAT checks if the software supports the business goal, processes, and rule it was designed for. During this phase, real-world scenarios are simulated and feedback is gathered from the users. They might take tests like placing an order, generating report, or navigating through the system to see if everything works smoothly. If the users are satisfied, the software gets approved for release, but if issues are found, they are reported back for fixes. This phase ensures that all business and user requirements are fully met before the software reaches production. When it comes to software testing, we don't rely on just one method. We use a variety of testing techniques depending on the scenario and what we are trying to achieve. There are three broad categories: black box testing, where we don't look at the internal code but focus on the inputs and outputs; white box testing, where we analyze the internal logic and structure of the code; experience-based testing, which relies on tester knowledge and initiative to find tricky edge cases. Some commonly used techniques include equivalence partition, where inputs are divided into groups that are expected to behave similarly; boundary value analysis, which checks how the system behaves at the edge of input ranges; decision table testing, great for business rules that involves multiple conditions and outcomes; state transition testing, used for systems that behave differently based on the current state or previous actions. Using the right mix of techniques allows users to catch a wide variety of bugs, from logical errors to UI issues, improving overall test coverage. In modern software development, especially with agile and DevOps practices, automation in testing has become essential. Manual testing, while useful, can be time-consuming and error-prone, especially for repetitive tasks. That's where automation tools like Selenium, JU, Test Engine, and many others come in. These tools allow testers to write scripts that then run test cases automatically, saving hours of efforts during each testing cycle. Automation is perfect for regression testing, where you need to ensure that new changes haven't broken existing features. It also helps in performance testing, where the system is tested under heavy load. Another big advantage is consistency. Automated tests can run the same way every time, reducing human error. Plus, they can be scheduled to run overnight or after every code, committing continuous integration pipelines. While automation doesn't completely replace manual testing, it definitely complements it by handling repetitive, large-scale, or data-heavy tasks efficiently. Ultimately, it boosts speeds, improves coverage, and increases confidence in the quality of the product. To wrap up, the V model emphasizes that the testing is not a final step, but an integral part of software development from the very beginning. By understanding verification, validation, and the different techniques, we can ensure better quality, reduced cost, and happier users. Thanks for watching.